Hello again, everybody. This is Frank Hunt, back to teach you more about electrical circuits, and in particular, today we're going to introduce you to Ohm's Law with this series circuit we talked about just the other day, the last time we were here. We have a source, right? In this case, we're going to use a battery source, 12-volt source. We're going to have a fuse in our system so we can monitor or limit how much current is going to go through that system. We'll put an ammeter on here so we can measure how much current is going through. And what we're going to do is we're going to take a light bulb that we're going to put into this circuit. And when you buy a light bulb, you buy it from the factory and you put it on the bench and you measure the light bulb, it's not going to change from one day to the next. The resistance of that light bulb is going to be the same. So let's say we buy a light bulb and it happens to measure out at 12 ohms of resistance. We put an ohm meter on it, we put them on the light bulb on the bench, and we measure it, and it comes out to be 12 ohms. Right? So if it measures 12 ohms, we can go to Ohm's Law now with some simple math and determine how much current is going to flow out of this battery, through this fuse, through this meter, through that switch when we make connection, through the switch leg, through the load with the 12 ohm resistance, and back to the battery. So this particular circuit, you notice in this circuit that there's only one way that the current can flow. Come out of the battery, go through this hot leg, go through the switch, go out the switch leg, go through this light bulb, and back. And we call this a series circuit. There's only one way for the current to flow. Right? So let's measure how much current is going to flow. We can predict in advance, before we turn the switch on, how much current will flow by this formula. E equals I times R. So don't get excited about too much difficult math. I'm going to show you this is as easy as 2 times 4 equals 8. If this were 8 equals some number times 4, what would that number be? It would be 2, right? And how would you get that mathematically speaking? You say like, well, you just look at the 8 and the 4, and you just divide the 4 into the 8, and this must be 2. So it would be something like this. 8 divided by 4 equals some number. And that number happens to be 2, doesn't it? So we go back to the letters, and we put in the letters. What is E? E is the voltage, right? So in the case, we have a 12 volt, right? Voltage divided by resistance, which we measured 12 ohms on the bench of this light bulb. So resistance is going to be R. So E over R equals what? Equals I. And in this case, our I is going to be 12 volts over 12 ohms. 12 over 12 equals 1 amp. So 1 amp of current. Current is the quantity of electrons, millions, gazillions of. Remember we were talking about gallons of water before? How many how many drops of water there are in the gallons, right? Like thousands and thousands of drops. So electrons are like that, and measured and counted in amps. So this is going to be 1 amp worth of electrons flowing through this switch, thrown through this light, thrown back. And that amount of current is basically controlled by the fact that there's 12 ohms of resistance. Suppose I took this circuit apart and put in here another resistor, another light bulb. Suppose I could cut into the switch leg here, and I say, okay, let me put in here one more light bulb right here. If I go like this, put in another light bulb, now I would have what? 2 light bulbs in what kind of a circuit? It'd be what we call a series circuit. This is our light bulb, right? All the current that's flowing through this switch, through this light bulb, goes through that light bulb, comes out, goes through this light bulb, comes back down here. And if these light bulbs are the same, let's add them up. One light bulb would be 12 ohms, and another light bulb would be another 12 ohms of resistance, right? So I got 12 ohm resistance, the current's got to go through there. 12 ohm resistance, the current's got to go through there. 12 and 12, 24 ohms of resistance in this total series loop here, right? Let's go back to the math. If we had the voltage of 12 and the resistance of 24, 12 and 12, right? We do the math on 12 over 24, and what do we got? 0.5 amps, right? 12 over 24 is 0.5 amps. So now how much current is going to come out of the source and go through this ammeter? Only 0.5 amps, not 1 amp. The 1 amp fuse will allow it to go, but the resistance here is holding it back, you might say, resisting the flow of the current to the point of 24 ohms, so only 0.5 amps are going to flow through that resistance circuit, that series circuit. And the more resistance you put in here, the less current will flow, right? More resistance, less current. Let me just take a minute to show you how this kind of is going to relate to what we're doing with the solar panel here in a minute. Let's go back to one light bulb. Back to one light bulb. You've all seen a situation where you have a battery, you turn on the flashlight, and you have a certain amount of light coming out of here. In this case, you would have 1 amp going through here, right? 1 amp. And that 1 amp going through this light bulb is going to create a certain amount of light with this battery source. What happens? You take the battery like you did when you were a kid into the tent, stay overnight, but you leave the battery on all night long, and over time the chemical reaction in this battery starts to get weaker and weaker, and the amount of current flowing gets to be less and less and less. But the light bulb didn't change. The light bulb was bought at the factory, and it's a 12 ohm light bulb. It didn't change. It's the same light bulb. How come it's putting out less light now? The reason it's putting out less light is because the amount of current now is less and less and less. But the light bulb didn't change, so what changed? The battery got weaker and weaker and weaker. Let's say the battery now is running out of juice here, running out of acid reaction. Now we only have, let's say, 6 volts of power in the morning. The other thing out all night is getting weaker and weaker and weaker. So what would the math show us about the voltage being E over R, right? The resistance is not going to change, right? So what if the voltage were now only 6 volts and the resistance was still 12 ohms? How much current would you have? 0.5 amps, right? You only have 0.5 amps going through this instead of 1 amp, right? You only have 0.5 amps. 0.5 amps going through this switch, 0.5 amps going through this one light bulb, and this light is going to produce less and less light than it did at 12, right? How does that relate to a solar panel? Suppose this source wasn't a battery. Suppose this source was a solar panel up on the roof, right? Now instead of a battery, it looks like this, right? And there's your solar panel, right? With all the things inside here, right? Now your solar panel is shining, putting out 12 volts because it's sunshine, noon, but then it gets to be 4 o'clock, 5 o'clock, 6 o'clock in the evening, and now you're going to be putting out less voltage than you did earlier in the day. So instead of putting out 12 volts, like it might in a sunny day, now all of a sudden it's only going to put out 6 volts. What's going to happen? You're going to be able to you're going to have less light showing on your light fixtures, right? We have ways of working on all that, but this is just the simple beginning part of what happens when you have less and less source, you have less and less current, so you have less and less light. Make sense? Okay, tomorrow we'll go into this a little bit further and we'll talk about parallel circuits. Thanks.